Hello everyone. In this video, we will try to study RS flip-flop, clocked RS flip-flop with the help of gates and IC. We can see this is the basic circuit diagram of our RS flip-flop using NOR gate, and for performing this experiment, we need two NOR gate, two bulb, two key, DC voltage power supply, and this is the truth table. So before starting this experiment, we will explore a bit about theory. So flip-flop is basically a sequential circuit, or which is also called bistable multivibrator, which has two stable states and it can stay in any of the state when input is applied. Even if we remove the input signal, then also it will remain in the same state. So in this way we try to store our data. That's why it is also called latch or basic memory unit or storage device, as it can store a bit of information. So now heading toward the RS flip-flop. So here we can see the schematic diagram of RS flip-flop. Basically, it is a flip-flop which has two input terminal, R and S, which stands for reset and set, and it has two outputs, Q and Q bar, and both are complement to each other. And it can be realized with the help of NOR gate. Here we can see the circuit diagram of an RS flip-flop using two NOR gate, and this is the truth table. That is for applying 0 0 input through R and S, there is no change in value. For giving R as 0 and S as 1, we will give output as a 1, that is the set state of flip-flop. And for R is equal to 1 and S is equal to 0, we will get output as 0, that is we will get a reset state for flip-flop, and for 1 1 it is not defined. So we can also analyze the RS flip-flop with the help of NAND gate. So here we can see the circuit diagram for the NAND gate, which is basically circuit diagram of RS flip-flop using NAND gate in dotted box. Here also we use two NAND gate, and it has two input terminal, and another input terminals are connected to the output, that is feedback to the output. So now we will connect our circuit and see the action of RS flip-flop. So now we will start the after connection, we will analyze this truth table. So basically, first of all, we will take a 3 volt DC power source and connect it with the key A as well as one of the terminal of key B. And now the key A is connected to the input terminal of first NOR gate, and key B is connected to this one of the input terminal of or NOR gate B. And now we will connect the output of first NOR gate to the one of the input of the bulb, and output of second NOR gate is connected to the second bulb, which represents the different states, that is the Q state and Q bar state. Now this second input terminal is feedback with the output, that is the input terminal of first NOR gate is connected with the output terminal of second and NOR gate. Input terminal of second NOR gate is connected to the output terminal of first NOR gate. So this is the basic connection for our RS flip-flop. We will verify our truth table. So as we are not knowing what is the initial state of Q or Q dash, so just for simplicity we will take that initially the Q will be at state 0 and Q dash will be state at 1. Now first case, as if input signal from R is 0 and S is 0, then we will not get any output, that is the flip-flop will remain in the intermediate state, means it will remain in the previous state as it was. And now as soon as we will apply the signal from R, that is 1, and set S to the 0, then it will set the flip-flop to the reset position. And as we provide signal from S, that is if we close the first switch, the flip-flop will be in set position. As soon as we will close key B, that is we will apply the signal from the S terminal, the flip-flop will be set in S state, that is the output of Q will be 1 and Q dash will be 0. Now as soon as if we will remove the input signal, that is if we open the both the switches, then also the flip-flop will remain in the same state as it stores our information. Now if we will apply the input from the R terminal, that is if we close the switch S1, then the flip output of Q will become 0 and output of Q dash will become 1, and this we will call the this will called the reset state of a flip-flop. So as soon as we will close switch S1, the flip-flop will set to the reset state. That is, we will get output from the Q dash, but output of Q will be remain 0. Now for the last case, if we will close both the key, then it will just a not defined case, because in this case we won't get output, or rather our memory get lost. So this is the basic problem occurs with the RS flip-flop. Now we will construct the RS flip-flop using NAND gate and also verify our truth table. We will construct RS flip-flop using NAND gate. For this we required 4 NAND gate, and also we required a 3-volt DC power supply. So first of all we will connect a 3-volt DC power supply to the key A as well as key B. Means the positive terminal of the voltage supply is connected to the key A and key B, and one of the input terminal of first NAND gate is connected to the A. Basically we are making a NAND gate into NOT gate. That's why we are shorting the both the terminals of the first NAND gate. Now similarly we will connect the terminal B to the input terminal of second NAND gate, and also we will short the both the terminal to make it into NOT gate. Now the output of first NAND gate is connected to the input of second NAND gate, and output of second NAND gate is connected to input of fourth NAND gate. Now the output terminal of the third NAND gate is connected to the one of the terminal of bulb, and second terminal of bulb is grounded, and the output terminal of fourth NAND gate is connected to the one of the terminal of bulb, and second terminal of bulb is grounded. Now we will apply the feedback. That is, the input terminal of third NAND gate is connected to the output terminal of fourth NAND gate, and input terminal of fourth NAND gate is connected to the output terminal of third NAND gate. So this is the simple circuit diagram, or basically the wiring connection of a RS flip-flop using NAND gate. Now we will analyze this truth table, but here the case just reverses as compared to the NOR gate flip-flop. So here in for the 0 0 signal we will get a forbidden case, and but for 1 1 signal from R and S we will get a intermediate state, that is the halt situation. Means the flip-flop will remain in the previous state. So this occurs just because we are inverting the R and S signal. We will construct a RS flip-flop using NAND gate. For this also we require 2 NAND gate, 2 bulb, and a DC power supply of 3 volt as well as 2 switches. So first of all we will connect the positive terminal of DC power source to the key A and also to the key B. Now the input terminal of first NAND gate is connected with the key A, and input terminal of second NAND gate is connected to the B. Now we will connect the output terminal of first NAND gate to the one of the terminal of bulb, and second terminal of bulb is grounded, and we will connect the output terminal of second NAND gate to the one of the input terminal of bulb, and other terminal is grounded. Now we will apply feedback. That is, the input terminal of first NAND gate is connected to the output terminal of second NAND gate, and input terminal of second NAND gate is connected to the output terminal of first NAND gate. So this is the simple circuit diagram, or basically the wiring diagram for a RS flip-flop. Now we will verify our truth table. So initially, as soon as we will start the circuit, so for 0 0 state we can't determine the output state of the flip-flop, because this is the case of forbidden. Now as soon as we will close the switch R, that is, we will apply signal through the R, and S will remain open, that is, the switch S will remain open, then in this case we will get state of Q as 0 and Q dash will be 1. That is, this is the called a reset a flip-flop. So as soon as we will close the switch S3, that is, the we apply signal from R, we will get output from Q dash as a 1 and Q as 0, and this is the reset state. So now as soon as we will close the both the keys, that is, this is the fourth case. in this case also the flip-flop will remain in the same state. That is, this is the intermediate state of a flip-flop it was earlier. So as it was set in the reset state, so it will remain in the reset state. Now for the third case, if we apply the signal from S and keep the switch R open, then this case we will get output of Q as 1 and Q dash will be 0, and this is called a set state of a flip-flop. So as soon as we will open the switch S3 and apply signal from S, then we get output from Q as 1 and Q bar as 0, and this is called a set state of a flip-flop. Now in this case also, if we will close the both the keys, then also it will remain in the same state, as this is the case of halt state. So this is the simple wiring diagram of an RS flip-flop using NAND gate, and hence we verified the truth table. Now we will see the RS flip-flop on IC. So now we will construct RS flip-flop using IC7400, which basically consists of 4 NOR gate. Here we can see A, B are input of first NOR gate and Y is the output, and 2A, 2B are input of second NOR gate and Y is the output of second NOR gate, and VCC that is positive power supply and ground is connected, that is the 7th pin is connected to the ground. And then we will make the flip-flop using NAND gate, that is on IC7400. So quickly we will start the connection. So first of all we will connect the R input terminal to the first input terminal of NAND gate, that is 1A, and S signal to the input of second NAND gate, that is 2B. Now we will connect the output of first NAND gate that to the Q, and output of second NAND gate, that is 2Y, is connected to the output Q bar, that is to the channel B. And now the second input terminal of first NAND gate is connected to the output of second NOR gate, and output or input of second NOR gate is connected to output of first NOR gate. So this is the simple connection. We will connect the last pin, that is the 14th pin, to the positive supply, and 7th pin to the ground. So this is the simple circuit connection, or basically the wiring diagram for RS flip-flop using IC74002. Now we will connect the other channel of oscilloscope, that is the negative channel, to the ground. We will also connect the key A and key B to the positive power supply, and now we will see the output. So initially we will assume that our Q, that is the Q state, is at a state 1, that is in the reset position, and Q at a 0 state. Now as soon as we will close the R switch, that is we will set the reset position, initially we will see that both the signals are 0, as no inputs are provided, so it will remain in its previous state. So as soon as we will close the switch R, the flip-flop came into the state of reset, that is we will get Q as a 0 and Q bar will be 1. As soon as we will open the switch, the output will remain unaffected, and then as soon as we will close the switch B, the output Q will be set to the 1 and Q bar to the 0. Now as again, if we will close switch R, it will set to the reset position, that is Q at 0 and Q bar at 1. So now we will analyze this output, that is the timing diagram, together in one go. So we can see that the output for when the flip-flop is set in set position, then we will get the output red line, that is at a high value, and yellow line, that is the Q dash value, will be 0. As soon as we will reset it, the Q will goes to the low output and Q bar will become at a higher output. And again for the next time when we will set the flip-flop, the Q value will rise to high level and Q bar will become 0. So this is the basic timing diagram for RS flip-flop using IC7400. And now quickly we will construct the RS flip-flop using IC7400. So for this, the first switch is connected to the input terminal of first NAND gate. and second switch is connected to the input terminal of second NAND gate. The output terminal of first NAND gate is connected to first channel of oscilloscope, and output of second NAND gate, that is the sixth number pin, is connected to the second channel of oscilloscope, and both the negative terminal of oscilloscope are connected to ground. Now we will connect the power supply, that is 14th pin is connected to the 5-volt power supply and 7th pin is connected to the ground. Now we will also connect the switch with the power supply of a 5-volt in order to provide the signal to the flip-flop. Now we are connecting positive power supply to the key A as well as to the B. We will also connect the second terminal of first NAND gate and second NAND gate to the output terminal of, basically the second terminal of first NAND gate is connected to the output of second NAND gate, and the second terminal of second NAND gate is connected to the output of first NAND gate. And now we will see the output after running the circuit. We'll start the connection. So initially at 0 0 state we will get a forbidden case, as in this upper line, that is the Q is also at 0 and Q dash will also at 0. So at initial state, at the forbidden case, we will get no any output as the both line are straight. Now as soon as we will close the R switch, we will set the flip-flop to the reset position, and that's why we will get the Q to the lower value and Q bar remain unaffected. That is, the initial state is assumed to be 1. Now as soon as close the second switch also, so in this case the flip-flop will be in a halt state, that's why the output won't get changed. And now as soon as we will open the R switch and close the S switch, then flip-flop will be set, will be in set state, that is we will get Q at a higher logic and Q bar is at a lower logic. And again if we will close the both the switch, then we will get a halt situation, and in this also we can easily see that output is not fluctuating. Now again if we will open the S switch, it will goes into reset state, and if we open the R switch, it will goes to the set state. And by just changing the input, we can change the output of the flip-flop. And so this is all about our RS flip-flop using IC 7400.